Alright, the rest of Chapter 10 is all about something called probability, and today we're going to focus on experimental probability. So we have to define a couple words on this page and the next one. You need to know what the word experiment means. Just like in science class, it's some activity that we do involving a chance of something happening. A trial is an incident of that experiment. So in science class, we talked about how you should do more than one trial to ensure that your first result wasn't a fluke. An outcome, same thing as the result. It's a possible result of what your experiment is. So your sample space is all of the possible outcomes. Like if we look at the first problem here, rolling a number cube, there's only a few outcomes. You can't get just any number. You're either going to get 1, or 2, or 3, 4, 5, or 6. Those are your only possibilities. You can't get 3.5, you can't roll a 7. So that is my sample space. Those are the only possible outcomes. Tossing a coin, we have even less outcomes. You're either going to get a heads or you're going to get tails. Only options. And then spinning the spinner. So when I spin that, I have a 1 in 4 chance of landing on these 4 colors of blue, green, orange, or red. That's it. I cannot get yellow, I cannot get purple, I cannot get chartreuse. My only options are blue, green, orange, or red. So now that we have those 4 definitions down, 2 more. Event and probability. An event is an outcome or set of outcomes in an experiment. And the probability is the measure of how likely that event is to occur. We measure probability on a scale from either 0 to 1 or 0% to 100%. So if you look at this scale right here, if something has a probability of 0 or 0%, that means it's never ever going to happen. There's no chance of it. If something has a probability of 100%, that means that there is no other option. That thing has to happen. We have to get whatever our event is. Right in the middle, 50-50 chance, that's kind of like our coins. You're either going to get heads or tails. Both of them are equally as likely. If you're on the side from 0 to 50, not very likely. On the side from 50 to 100, you're more likely. So let's do some actual problems. Calculating experimental probability. So the probability of any event happening is the number of times that that event occurs in our experiment divided by the number of trials we did. Remember, we're doing experimental probability. So this is what really happened when you did an experiment. So we're given something called a frequency table, and this holds our data. So someone spun a 3-color spinner, and they spun it a couple times, and they got red 7, blue 8 times, and green 5. The first thing we should do is figure out how many times they spun the spinner. So if we add all those up, we get 20. We're going to need that for the bottom part, the number of trials we had. So the first one, the probability of getting a red. Based on our experiment, I got red 7 times out of 20. So we can leave it as a fraction, or we could turn it into a decimal, 0.35, or we could turn that into a percent. 3 options, 3 different ways to write this. Since it starts off as a fraction, I'm totally fine with you leaving it like that, so you don't have to do any more work. Try figuring out the rest of these right now. Go ahead and pause the video. So hopefully you have the probability of blue and green correct. The next 2 are a little tricky. So probability of getting a yellow. Based on our experiment, we never once got a yellow. It's a 3-color spinner, so that means we only had 3 options, and yellow wasn't one of them. So the probability of getting yellow is 0. Not 0 out of 20, that is technically 0, so it's just 0. There is a 0% chance that I will ever get yellow. The probability of getting not blue, you could do a couple different ways. First way is just figure out how many other times we spun something not blue. So red is not blue and green is not blue. If you add those guys up, you get 12. So you could do 12 out of 20. The other thing you could do is go back to our probabilities that we had over here and forget about the blue. Probability of getting not blue is 35% plus 25%. And if you add those up, you get 60%, which is the same thing as 12/20ths. Last page, let's do an extension problem. Experimental probability scores can be used to make predictions. A prediction is an estimate or a guess about something that hasn't happened. But based on an experiment, we can use our data to extrapolate that, to find a prediction. So here's an example. A manufacturer randomly inspects 800 light bulbs and finds that 796 of them have no defects. So the probability of having no defects is the number in our experiment, 796, divided by the total number of light bulbs I looked at. So now, if a business wants to order 3,000 light bulbs from this manufacturer, how many of those are likely to have no defects? So what we're doing here is coming up with a proportion. If we expect our probability to be the same as the 796 out of 800, now I can use that to figure out how many I would have out of 3,000. So this is the number up here that we don't know. We don't know how many would have no defects out of our total of 3,000. But we're saying that the probabilities are the same. So what we can do is do some cross multiplication and figure out what x equals. So if you do 796 times 3,000, we're going to get a big number. You get 2,388,000. And then on the other side of that, it's going to equal 800 times x. So if we divide both sides by 800, makes our number a little smaller. We get that x equals 2,985. So if our probability holds true, we can make a prediction that if somebody buys 3,000 light bulbs, 2,985 of them are going to have no defects. And this is something companies actually do when they figure stuff out. They test a small sample size and then use that probability to extrapolate your data into something way bigger so that they're not actually counting out 3,000 light bulbs.